What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are doing virtual contest 683. I was able to solve the first problem, but now I'm just up solving numbers box. So yeah, basically I started this before I actually started live streaming though. But yeah, now I'm just trying to solve the second problem. So I'm thinking about so basically you're given n rows and m columns, and you have the option of multiplying two adjacency cells by -1. And then basically we're trying to find the maximum sum to achieve, right, of all the values in the matrix. So what I'm doing is that basically I realize if you have a 0, then you just sum up all the values, right? If you have a 0 here, you just sum up all the absolute values here. And I think that's what got it to 30. I'm not sure if that's 100% right, but I think it makes sense though. Okay, now what I'm doing is that for every two values, I'm just checking every two values. Then I'm just checking if the absolute value is greater than it. So if like 2 and 2, so if one is negative, if one value is negative, then we could make so if one value is negative, then we could change. We check the absolute value of then we could change it, right? So like, let's say we have like -1, -2, right? If one value, okay, fine, never mind, -1, 1, right? So we let's say this 1 was actually a 2. We could actually flip this to become +1, -2, right? If you do that, then your sum actually decreases by -1, right? So it's actually better if you have the larger absolute value become the positive if it's negative, right? So that's basically what I'm trying to do here. So now that I realize that we should actually check if either of the values is negative. So like if d of ij, the current value is less than 0. We're also checking if the one right next to it is less than 0. So if one of them is, if the current is less than 0 and the one next to it is less than 0, we need to find the one with the maximum absolute value. So yeah, let's actually do that. So let's do like max absolute. So that's going to be if ABS of the absolute value of the current value we're searching through is less than, okay, if it's greater than the absolute value of the one next to us, right? Then we could do then it's max absolute value is this one, right? Otherwise it's this one. So yeah. Yeah, so we need a question mark here. So this is a ternary operator. Yeah, otherwise it's this one. And then we're making this absolute value. Okay, yeah, I think that should get you the, so now we have to flip the one with the larger one to have positive and the one with the negative one, the smaller one to be negative, right? So whichever value is this one, we just make this positive, and whichever is the smaller value, we just make it negative. Let's see. Can I set a current value to it? Let's see. So this is like the one with the larger value. So let's call this larger. Okay. So basically, I'm just going through the whole the whole matrix, the whole value of the whole arrays, the 2D arrays like this, and I'm just checking like every two, seeing whichever is the larger value. Then I make that, if that is negative, then I make that positive. If the smaller one is negative, I make that negative also. If the smaller one's positive, I make that negative. If they're both positive, if they're both negative, we just make them negative. Yeah, if they're both negative, we just make them negative. So yeah, I'm trying to see something. Actually, let's not do absolute. let's actually set them to become negative, and then let's sum them up in the end. Okay, so yeah. Okay, so we have this. So this is the larger one. Let's get the smaller one now. So the smaller one's the exact same thing, except it's going to be like flipped. So this would be, if it's smaller, then do the left side. Otherwise, do the right side. Yeah. So this is assuming they're both, at least one of them is negative. At least one of them. So one's negative, one's positive, if they're both negative. Okay, if they're both negative, you just have to make them both negative. So is there a positive or negative? Both negative. Positive 11. Okay. So in this case, we just set crap. So we have a variable here. We don't need so just set the larger one to become negative and the smaller one to become negative. Yeah. So just whichever larger, set it to the negative. So that means that in our total sum, we're gonna add up. So we have to add up the smaller and the larger values. Now, if it's negative, if one of them is negative, let's see, if one of them is negative, okay, so whichever is the larger one, make that negative. Yeah. Actually, no. So let's say we have 3, -1. If we make the large one negative, then it would be -3 and 1. So that's not a good idea. We have to make sure they have different signs. So if the larger one is actually larger than the smaller one. Oh, make the smaller one. Wait. I'm trying to think. This is number 2. This is problem number 2. Codeforces 683. Problem B. Let's see. If number of positive numbers is even, you can make all positive. Oh, and number negative is even. Oh wow, isn't it at like 7? Wait. Dang. Well, if you have lecture soon, then I don't want to stop you from going to lecture. Okay, sure thing, Cyrus. Sure thing. If number of negative numbers is odd, you could just move negative to the least number. Yeah, that's what I was thinking. Yeah, that's what I was thinking. But so wait, so we don't actually have to sum them all up? Wait, we don't actually have to sum them all up then. So I don't have to do all this actually. Yeah, so Cyrus, not Cyrus, Chethan. Yeah, that is exactly what I was thinking. So like if you have like a smaller negative, if the number of negatives is negative, you could just make the smallest one become negative. That's what I was thinking. So yeah, let's actually get rid of some of this stuff. So we don't actually need this then. We don't need this. So we just need to check if the number of negative numbers is less than 0. So we have to do -0, neg plus. So if neg mod by 2 is not equal to 0, so this means that it's a odd number, we have to set the smallest value to be negative. So let's actually get the smallest value here in our first part. So this is going to be smallest we have to do like a let's do long max. Make this very large first, and then what we're going to do is we're going to compare every single one of this and then divide nj. Okay, so this gets us our smallest number. Why is this not working? You know what, let's make this integer. Okay, I don't feel like changing anything. Okay, if the number of negatives is not equal to is even, okay, so otherwise, so let's actually make a sum. Let's see total sum. Let's create a value total sum. And this is just going to add up all the values while we're iterating through it. So we're going to add up all the values here and here. Yeah. So yeah. Okay, now we're just going to make total sum. So if it's number of values negative, then we must see print total sum. We don't need this. We don't even need sum. Otherwise, we make the smallest value negative, so we print out total sum minus smallest value. Okay. I think this would work. Not 100% sure. So this has to be absolute. Yeah. Maybe it's plus, because smallest value might be negative. Minus ABS. I don't know. Let's actually just submit it. Like, we could submit it as many times. It's a virtual contest. Let's see. Okay, wrong answer. What's the problem? I got 3. Okay, so we have smallest one is 1. Oh, 2 minus 1. Okay. In this case, let's just add. Then let's do the knapsack after this. Okay, what is the problem? Why is it 3? Something's not right. How many negatives are there? Let's actually copy this. Okay, how many negatives are there? There's 1 negative, so it's not equal to 0. What's the smallest value? -1. So we have 4 minus negative. Oh. Okay. That'll give you 3. Let's see. If it's odd, just make the smallest value negative. What is the smallest value? Smallest value is 1. -1. Do you just sum them up? What if you have to add up all the positive values? There's a small bug. If there's 0, make that negative while taking the minimum, i.e. 0. Make the smallest value negative. So you're saying here, make this negative? But like if you do absolute value of that, oh yeah. Okay, wait a minute. That doesn't make sense. Wait. Hold up. Let me try something. Is it this one? Nope. Just traverse the whole array and add sum. If sum is less than 0, make it positive. Otherwise, print sum. Sum is less than 0, make it positive. Otherwise... So you're saying making everything positive? Because that's not... Okay, now I'm getting 1. That's not right. So I'm off by 1. Oh, plus this? Hold up. No, I'm still off by 1. Let's see. If I do that. $29. I'm still off by 1. Total sum minus. Total sum is... Total sum is 4. Smallest value is... Total sum is 2. Wait. No, I'm not gonna check your submission. Let me see. You end up having just on one negative number. If you... Okay, so it won't work. Absolute value is negative. Traverse the whole array and add sum if it's less than 0. Make it positive, then print sum. Are you sure about that? Because then that's just making everything... That's just going to add up all the absolute values. Right? Let's see. We're 1, negative 1, positive 1, negative 1. Okay, so we have 1, negative 1, 1, negative 1. So let's say we have... Okay, so we're going back to here. Is it minus 1? No, wait. Total sum is 2. Oh, wait. Equals 0? Nah, that's not right. Just make it all long. It's just being sure. Okay, now... Whoa. Now I'm getting 5. 30. Hold up. How's making long get me 5 and 30? Okay, I have 3 and 30. Add up absolute value. So we add up absolute value, we have 4. Okay. Minus 1. No. 2. Smallest value is negative 1. Number of negatives is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11? Make the smallest value negative. Make the rest positive, right? Make the smallest value negative, make the rest positive. Oh, I'm double counting. Hold up. Okay, we got to make the rest positive, right? So if the rests are positive, so in this case, if the rests are positive, so let's say we have negative 1, 1, 1, 1. So the total sum is 4, right? We need to make the rest positive and the smallest value negative 1. So smallest value, absolute value is 1. We make that negative, so that'll be negative 1. But we also need to subtract the smallest value from the total sum to get rid of the initial absolute value of the smallest value. If you guys know what I mean. So like we need to do so total sum includes the absolute value of smallest value. So we need to subtract the absolute value of smallest value. I think. So now we have 2. Okay, yeah. So the same thing as this. Something's wrong with my. Okay, no, we have 30 now. Smallest value absolute is negative 1. So let's see, 2 plus 3, 6. No, 5. 5, 6, 8, 11, 15, 17. 17 plus 7 is 22 plus 5. Wait, hold up. Yeah, 22 plus 5 is 27. Let's make the smallest value negative, so 26. Why is it printing out? Let's see, 1 plus 2 is 3 plus 3 is 6 plus 1. How many negatives are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 negatives. Let's see. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 2 is 8. 8 plus 3 is 11. 11 plus 4 is 15. 15 plus 5, 20. 20 plus 9 is 29. 29 minus 1 is 28. 28 minus 1 should be 27. So something's not even right. Hold up. Let's see. Hold up. Okay, so let's see. Number of negatives 11. Smallest value is 0. How smallest value is 0? Oh. Yeah, smallest value is 0. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 3. 6 plus 3 is 9. 9 plus 9 plus 7, 16. 16 plus 5. 16 plus 5 is 21. 21 plus 9 is 30. Yeah, I don't know why. Why is the answer 25? 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 3. 9 plus 7. 16 plus 5. 21. 21 plus 9 is 30. Why is the answer 25? Wait, it is 30. Wait. Wrong answer on 2. You know, I realize we don't actually need this. Let's see this again. Let's see. Oh, no, yeah, now it works. Okay. Yeah, that got AC'd. Okay. Yeah. So our issue was that we were counting twice. That was the reason why. Okay. Yeah. Yeah, okay, yeah. Now I just realized, yeah. Okay. Yeah, okay, guys, yeah, I just realized that. Now let's do the knapsack problem. The knapsack. Okay. A knapsack, a weight of W. There are N items. The ith one has weight WI. We want to put these items in a knapsack in such a way that total weight is at least half of its size, but obviously does not exceed it. Okay, so output list items you put in a knapsack. You don't have to maximize the weight in the knapsack. There's several ways to do output any. Okay, why don't we just loop from W over 2 to W? Then check if our total weight capacity. Yeah, so we loop from W over 2 to W. And then we check, we need to add up all the items that have weight of C, of W over 2 to W. So, yeah. Okay, let's try doing that. Okay. Let's see. Let's get rid of this. Okay, so we have N and I have W. Let's create. These are small W's, right? Small W's. Yeah, let's actually create small W's. Yeah. Okay, so now I have the small W's. And now what we're going to do is that we are going to loop through from different capacities from big W. Ceiling of W over 2. C is less than, actually, let's make this long. C is less than W, C++, big C. Okay. So this is going to be our capacity, and now we're going to try all the items. Okay, subtract all the items for each capacity to see if it works or not. So we actually could do this recursively. Yeah, so what we're going to do is that we're going to pass in the W. So we're going to do like a check capac. It's going to be C, and it's going to be passing our weights and our capacity. And we're going to recursively call this function until we reach a weight of 0. And then we're going to pick the values that C. Okay, so every time we're going to pick C minus each weight, if that makes any sense. So like if we're going to pick, so our total capacity is C, we're going to C minus W of 1, W of 2, W of 3. And to see if there's one equal to that, yeah, we're just going to do that. What are we trying to do actually? If there's several conditions, output any. Okay, so if there's several conditions, just output any. Such that the capacity is at least half of its side. Can we just pick all the largest weight then? We could just pick all the largest weight. So like weight C. Largest weight less than C. Can we do that? So we could use like binary search and sort it. I'm trying to think. Yeah, yeah, I know it is a greedy problem. The thing is that, so you want to put it such that the total weight is at least half of its size. So if we're going through all the weights of this, we need to keep subtracting. We could keep subtracting the smallest weight actually. Let's actually do that. So before this happens, we'll sort W. So we sort all the weights. So if this is possible, then we just break, right? Then we already printed it. If it's not, so that means none of this was possible, then we see out -1. Okay. Wait, pos. Otherwise, print out -1. If it's possible, then we just have to print out the array, the list of values that we add. So, yeah, for the problem, maybe we should check if the array is empty or not. Okay, let's see something. The capacity has to be at least half of its size. I think we could just pick all the smallest ones. Yeah, that's what I'm doing. I don't know. Oh yeah, okay, so this is what we could do. We could create a new array every time. This is gonna be our list. Now we could pass the list in here. Okay, so now we just do check cap. The weights, and then this is gonna be our list. Okay, so now what we're gonna do is we're gonna recursively call this function, and then we're gonna subtract c minus weight of I. And then we add it to our list. Technically, we could do this iteratively, yeah, actually. We could actually just go through the list this way. Let's actually do that. Let's not do it recursively. I know the knapsack problem algorithm is recursively. But let's actually... Wait, I could just use a regular index. Now what we're just gonna pick the first value every time. So if c is greater than let's do it like a total weight. Okay, so if total weight is less than c, we'll pick the weight. If so total weight is less than c, we'll just pick the first ith value. So we're gonna do total weight plus equal to weight at I, right? The ith value, ith weight, and then what we're gonna do is we're gonna do like a actually let's create like a temp c. Temp c is gonna equal to c. Okay, now what we're gonna do is we're gonna set, so this is temp c. If it's less than temp c, then we're gonna do temp c minus equal to the weight at I. Yeah. Yeah, and then at the end we need to add the weight to the list. So we do list.pushback. Okay, so that should work. So if the list is not empty and the total weight is actually we didn't even need the total weight. We could have just done temp c is greater than 0. Yeah, why didn't we do that? Let's actually do that. That makes more sense. If temp C is greater than 0, we add the current weight, and then we subtract temp C by the current weight. And then we push back. So now let's see if our total weight is equal to C. Okay. We can't pick way more than what we need, right? Excuse me. Okay, so if list is not empty, positive is true, so it's possible, and then we break. And then here we're gonna print out the list. So, oh crap, the list is in here. Okay, so let's actually make the list on the outside, and what we're gonna do here is we're gonna clear the list every time. Okay, yeah. So and then at the end of this, we just print out the list. Okay, let's try this. All right, we are not getting the right one. You could take a weight item weight 3 to fill the knapsack just right. Wait, what do they want us to print? Oh, they want us to print the actual size of it also. Okay. Let's see if this works. Okay, so we have 1, 3. 3, we could pick 1, right? Fill knapsack just right. Why is it 1? Oh, indices of the item you would want to pack into the knapsack. What the? Who does that? That's super weird. Okay, indices of the item. Okay, that's like I plus 1. Ah, crap. When we sorted it, we changed the indices. Okay, so that means that, okay, this is really annoying. We need to actually push back the indices with the current pair so that we could actually keep the order. So we're gonna actually, crap. Okay, w.pushback. Okay, so I need to create a variable red. Okay, now we're gonna do like w.pushback. Red, and then the indices. They want index by 1, right? Yeah, they want index by 1, so that's what we're gonna push back I plus 1. Okay, so now once we have this, total weight is gonna be w at I plus first, minus I dot first. Push back w of I. Here's gonna be a problem. Where's the list? Does it have to be a pair? Okay. So now here's the problem, is that you're going to loop through here. You're going to actually print out the indices. Okay. Okay, so 1, 1. Do we have a -1? -1. Oh, there's a -1. There's a negative 1. Why is it not possible? Is it because wait, does it have to equal exactly the capacity of C? Oh, maybe that's the reason why. Okay, so don't do it when the list is not empty. We also have to check if the total weight is C. Let's see if this works. Okay, so we got -1. Okay, that's good. 1, 1, -1. 6, 1, 2, 3, 5, 6, 7. Okay, I think this works. Wrong answer on 2. What are we doing wrong? I don't want to look at it. Let's read the chat. Let's read the chat. Let's read the chat. Current approach is going to get TLE. Does competitive programming help you become a good software developer or a software engineer? It helps you become a good programmer, like small programs. That's what competitive programming helps you. Does it help you become a good developer? No. In terms of like building large systems, no. That's like if you're gonna build like large systems, maybe you should like actually build large systems. I don't know, get a job doing stuff like that. But I mean, it helps you think. It helps you become like a decent programmer. Your current approach is going to get TLE. You have to print the index. This is a common problem where they ask the index. What? How could you just do this? Or how can you just check if one element is the case? But then, like, okay, if not the first case, then keep adding all the elements that are less than W over 2, and at some point you'll satisfy the condition. I don't think our case is going to get TLE. We're getting wrong answer. That's the problem. Because like the knapsack algorithm does a different thing. And I mean the one where you use 2 loops, that was gonna get TLE. Let's see. Oh, what the? You could use... Should we use dynamic programming? I bet. This still gives TLE. No, my answer gives wrong answer. You know what? Let's actually look at the wrong answer. I can't look at the wrong answer. For loop from 1 to n, for loop from 0 to w. If the value is greater than it, then set the most optimal solution to the previous one. Otherwise, subtract j minus plus the weight of j. I mean, we could do this way. No DP in this case. No DP in this case. All right, I'm actually gonna eat breakfast. So yeah, I hope you guys enjoy this live stream. I'm probably gonna do this again soon. Maybe tomorrow. I'll do this tomorrow, same time. But yeah, I hope you guys enjoy this live stream. Rate, comment, subscribe. I'll try to figure out this problem on my own. But yeah, rate, comment, subscribe. I'll check you guys later. Peace.